Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss one more numerical question on shortest remaining time for scheduling algorithm. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Consider the following set of process arrived at 0 units of time with the below burst time and priority. A smaller priority number implies high priority. Process A, B, C, D, E has arrived at 0 units of time and priority is 31542. A smaller priority number implies high priority. So process B will have the high priority and process C will have the lowest priority among the 5 processes, and their burst time is 4, 1, 2, 1, 4 respectively. Using shortest remaining time for scheduling algorithm, find the average turnaround time. They have given 4 options. We need to solve the question and find out what is the right answer. Any scheduling algorithm will have 2 parameters. One is the criteria and another one is mode. Now coming to the shortest remaining time for scheduling algorithm, the criteria is burst time. So the process, among the process which are there in the ready state, the process which has the lowest burst time will be dispatched to the running state. We have two types of scheduling algorithms. One is the preemptive scheduling algorithms and another one is non-preemptive scheduling algorithms. The shortest remaining time for scheduling algorithm will come in the category called preemptive scheduling algorithm. Is it clear? Now you will ask me one thing. Sir, in shortest remaining time for scheduling algorithm, what is the need for the priority? I will discuss for you this point. Let's consider that the two processes such as P1 and P2 are there in the ready state. And their burst time is, let's take that 5 units and 5 units. So, the two processes are there in the ready state and they have the same burst time. So, there is a tie. Usually whenever there is a tie in the shortest remaining time for scheduling algorithm, we will look at the arrival time. The process which has arrived first will be scheduled to the running state. But here all the 5 processes has arrived at same units of time. Okay, then what we need to look at? Then we need to look at the priority. The process which has the highest priority will be dispatched to the running state. So the priority will help you in the tie breaking. Is it clear? So with this knowledge, let me solve this question. So for any scheduling algorithm, if you want to compute the completion time, turnaround time, waiting time, we need to first draw the Gantt chart. Okay. Always the Gantt chart will start from 0 units of time. Okay. In the ready state, what are the processes arrived at 0 units of time? Process A, process B, process C, process D and process E. Now which process will be dispatched to the running state? It depends on the burst time. Process A needs 4 units of CPU time, process B needs 1, process C 2, process D 1 and process E is 4. Is it clear? Now among all the numbers, process B and process D has the lowest burst time. So there is a tie between B and D. Now you need to look at the priority. Process B has the highest priority. So process B will be scheduled to the running state. Okay. Now process B will run for 1 unit of time and it needs only 1 unit of time. So process B has completed its task. Okay, are you able to understand? Let me not cross it. Process B, after 1 unit of time, it has gone to the terminated state. Okay, now there is only 4 processes such as A, C, D, E. Now we need to look at the what? The burst time. Now process D has the less burst time. So process D will be dispatched to the running state. Okay, and process D will be run for 1 unit of time. Okay, then its remaining burst time is 0 units of time. So at 2 units of time, process D has completed its task and will go to the terminated state. Is it clear? So right now A, C, E are there in the ready state. Now among A, C, E, which process has the less burst time? Process C. It will be dispatched to the running state. Okay. It will run for 1 unit of time. Its remaining burst time will be 1 unit. Am I right? Now look at the process. Process C is there in the running state. Process A and E are there in the ready state. Now among these three processes, process C has the less burst time. So again process C will be running for 1 more unit of time. Okay. Process C will be run for 1 more unit of time. At 4 units of time, process C will complete its task and will go to the terminated state. So now process A and E are there in the ready state. Is it clear? Are you able to understand? Now process A and E has the same burst time. Now we need to look at the priority. Process A has the priority number 3. Process E has the priority number 2. Now if you look at this point, a smaller priority number implies high priority. So process E has the lowest priority number, so it has the highest priority. It will be scheduled to the running state. Okay, it will run for 1 unit of time, then its remaining burst time is 3 units. So process A is there in the ready state and process E is there in the running state. Now among this one, which process has the less burst time? Process E. So again process E will run for 1 more unit of time and its remaining burst time is 2 units of time and process A is 4 units of time. Now among A and E, which has the less burst time? Process E only. So again process E will be running. Is it clear? Suppose if process process E is 2 units of time, if any process in the ready state has less burst time, then it will be preempted and the process which has the less burst time in the ready state will be scheduled to the running state. So there will be a context switching. But here the process which is there in the running state has the less priority as compared, not less burst time as compared to the process which is there in the ready state. So the same process will be running till 8 units of time. Is it clear? So process E has completed its task at 8 units of time and will go to the terminated state. Now only one process is there, so that process will be scheduled to the running state and it needs CPU 4 units of time. It will be given 4 units of time and at 12 units of time process A will complete its task and will go to the terminated state. At 12 units of time, all the 5 processes have completed the task. If you have a doubt, you can check it. A needs 4 units, B needs 1 unit, so total 5, 7, 8, 12. So at 12 units of time, all the 5 processes has completed the tasks. Now with this knowledge, we will compute the completion time of each process. By looking at the Gantt chart, we can easily find out the completion time of each process. Process A has completed at 12 units of time, process E at 8 units of time, process C at 4 units of time, process D at 2 units of time, process B 1 unit of time. Now they are asking us to compute the average turnaround time. So first let me compute the turnaround time. Let me erase this one so that I can find this one. Okay. Now turnaround time is equal to completion time minus arrival time. Turnaround time is equal to completion time minus arrival time. So arrival time is 0. So anything minus 0 will be the same number. Meaning is that 12 minus 0 is 12 only. So 12, 1, 4, 2, 8. As the arrival time is 0 for all the process, so turnaround time will be equal to completion time. Now they are asking us to compute the average turnaround time. Average turnaround time is equal to sum of all the process turnaround time by number of process. So which is 12 plus 1 plus 4 plus 2 plus 8 by 5, which is equal to 13, 17, 19. 19 plus 8 is 27, 27 by 5. If you have a doubt, you can verify again. 12 plus 1 is 13, 13 plus 4 is 17, 17 plus 10 is 27, 27 by 5 is 5, 5 is 25, you will have 2 by 5, is it clear, which is nothing but 0.4, so which is 5.4 is the average turnaround time for this question. So option A is 7.2, which is wrong. Option B is 8.2 is wrong. Option C is 5.4 is correct. Option D is 6 is wrong. So for this question, the right answer is option C. I hope you have understood how I solve this question. If you still have any doubts related to this question or related to the shortest remaining time for scheduling algorithm, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.